All right, my little geometry geniuses. Today we are in activity 4, lesson 4.1, segments and midpoints. So today we are going to apply the segment addition postulate to find lengths, and then use the definition of a midpoint to also find the length of segments. So make sure you have your book ready to go to take notes, something to write with, and your activity for vocab sheet, because we are having more and more vocab words today. Okay, so we're going to start by talking about postulates. Okay, and in geometry, a postulate are statements that are accepted as true without a proof. Okay, so for example, here, the length of a line segment is the distance between the two endpoints. Okay, we don't have to prove that statement, it's just something that we always accept as true without actually a big long proof when we start our deductive reasoning, okay, or making proofs. So on this first page, they kind of just have us go through measuring something on a ruler. So I'm going to actually skip that and just jump here to question 4. So jump to question 4 in your book. Okay. So we have given that N is a point between the endpoints M and P of a line segment MP. We're going to describe how to determine the length of NP without measuring if you know the lengths of MN and NP. Now, when we start getting into this section, it's really important that we start drawing pictures, okay? Because it's going to get really wordy, lots of points and things and definitions. So if we can draw pictures to kind of help us make it a little easier for ourselves, then let's do that. So let's look at a line segment here, okay? And they said we have line segment MP. And they tell us that N is a point between those 2 points. So we have N. So they're asking you to describe how you would find the length of this total segment without measuring, but you know the length of NP and you know the length of MN. So how would you find the length of the total segment if you only know the length of the 2 little parts in between? Okay. Hopefully you said something like this, that you would just add those 2 parts together, and then that would give you the length of the entire segment, okay? So that is what we would call segment addition postulate, okay? So the segment addition postulate just says if you have a line segment and you know the value of the 2 parts inside or multiple parts, whatever it is, you can add those together to get the length of the whole, okay? So let's look at 5A. So we're going to use the segment addition postulate and the given information to complete each statement. So again, I have segments kind of drawn out here already, so make sure you're drawing them in so you understand what we're talking about. But let's look at what is given to us. So if B is in between C and D, okay, so C and D are my endpoints. And they're saying that B is somewhere in between there. Okay. They're telling us that BC is 10 inches and BD is 3 inches. We're going to find the length of CD, the entire line segment. So according to this addition postulate, I can take the line segments of CB and BD, add them together to get the length of the whole. So 10 plus 3 would give me 13. Okay. So let's look at B then. We have Q lies between R and T. So let's label this. We have R and T with Q somewhere in between. They're telling you that RT is 24 centimeters. So let's label this. RT is our entire segment. So they're saying that is 24. And QR is 6. So they want you to find the length of QT. So this little segment here. So why don't you guys try that? What is the length of QT? Okay, hopefully you said that QT then would have to be the total segment minus the length of RQ. So that would leave us with 18 for the length of QT. Okay. All right, and C, they're going to throw a little algebra at you here. So let's look at what we got. We have P lies between L and A. So we have L A, P is somewhere in the middle. And they're telling you that PL is equal to x plus 4. And PA is equal to 2x minus 1. Now they told us that LA, the entire segment, is 5x minus 3. So they want us to find what x is and then actually solve for what LA, the length of that segment, is. So I'm going to help you guys set it up, and I'm going to have you solve it. So according to this postulate, we can take our first little segment, add it to our second little segment, and that should equal the entire length, right? So if I have x plus 4, and I add 2x minus 1, according to our postulate, that should equal the length of the entire segment. I'm going to have you guys go ahead and solve that for me. So solve that for x. Okay, we should have got that x was 3. So if x equals 3, what is the length of LA? Okay, if we plugged in 3 for LA, we should have got that this length is 12. Okay, so just want to reiterate, it's really, really important to start drawing pictures and labeling your pictures, because that's going to make your life a lot easier. Okay, so that is our segment addition postulate. So let's continue on and show how we use it with midpoint. So a new vocab word here. The midpoint of a segment is the point on the segment that divides it into two congruent segments. Okay, so really quick, congruent, in case you didn't know, congruent figures have the same measure. So if it cuts it into two congruent segments, that means two equal segments. Okay, and a lot of times for congruent, we will use this symbol, okay, equal sign with a little squiggle above it, which they show here. Okay, so that's what that means moving forward. So in this particular picture, we have a segment AC. If B is the midpoint, that means that this segment is equal to this segment. Okay, so AB is congruent to BC. All right, so let's do 6. It says M is the midpoint of RS. So again, let's make sure we're drawing some pictures here so we know what we're talking about. RS. And M, they're saying, is our midpoint. Okay, so if RS is 10, so that RS, that's the entire segment. So if that is 10, what is SM? So we're figuring out what this is. Okay, well, if this is a midpoint, that means that these two segments are congruent to each other. They're the same. So what would it be if we have two equal segments that add to 10? That would mean each little segment would have to be 5, right? Okay, let's look at what B is asking. If RM is 12, so let's make, so we have the same picture here. So I'm just going to erase this part. Okay, so in this case, they're saying if RM is 12, then MS is what? Okay, well, hopefully you said that since they are congruent, it's the same measure, right? And then what would that make RS then? Well, RS, so 12 plus 12 would give us 24. Okay. All right. Let's see here. So I'm going to have, let's see, I'm going to skip this. Let's going to jump to number 11. So on number 11, it says you can use a number line to find the distance between 2 points. Okay, so you guys are familiar with number lines. We've used them before in the past. But if they asked you to find the length of LM, what would you do to find that? Okay. Well, according to your book, they would say, well, if this point's at 4 and this point's at -3, then if we subtract those, we should find how much it is between them. Okay. So minus minus turns to plus plus. We would get a length of 7 units, right? So that's how your book decides to do it. But honestly, if I have a visual, I would rather just count 1, 2, 3, 4, 5, 6, 7. So I'm not going to make it harder than it needs to be, but there you go. And remember, a distance has to be positive, okay, because it's a length of something. So even if you got a negative sum here or a negative difference, you would just take the absolute value of that. But I just wanted to point that out really quick. Okay. All right, so the midpoint of a segment is halfway between its endpoints. So if you know the coordinates of the endpoints, you can average them. So average, you take your two values, you add them up, right? So value 1 plus value 2, and to average them, you would divide by how many numbers you have. Okay, so you can average them to find the coordinate of the midpoint. So your book says that we could take 40 and add it to 8 and divide by 2. Okay, so 40 plus 8 would be 48 divided by 2. Our midpoint then is at 24. Okay, or honestly, what I would just do is say we have 1, 2, 3, 4, 5, 6, 7, 8 in between there. So the midpoint has to be half of that, or 1, 2, 3, 4. That's the middle. Okay, so both ways I think work. That was just a picture your book had. Okay, so I'm going to have you guys try 13, just A and B really quick. So use the number line to solve each problem. So for 13A, they want to know what is KL, meaning what's the length of KL. Hopefully you said that it was 24. Okay, so if you didn't get 24, just make sure you're looking at the actual numbers on the number line because they're going up by 3. So this might be a case where you might have wanted to actually do the subtraction, 15 minus negative 9. Okay. All right, so looking at this then, what's the coordinate of our midpoint for KL? So where's the midpoint? All right, so our midpoint should be at 3. So again, since we're just finding the middle here, I think counting is fine. 1, 2, 3, 4, 6, 7, 8. So that would be 4. 1, 2, 3, 4. There's my middle. Okay, but again, I could have averaged these 15 plus negative, plus negative 9 divided by 2. Okay, both ways work. Okay, so moving on. We have a lot to cover in today's lesson, so I'm just trying to make it efficient. All right, so the last thing we're going to do is look at how we can use the definition of midpoint and properties of algebra to determine the length of a segment. So we're doing lots of algebra in this problem and solving equations. So again, make sure we're drawing those pictures in, okay, to help you out a lot when we do these problems. But let's look at the try these A. So it says, y is the midpoint of WZ. So I'm just going to fill that in really quick. I have a segment, WZ, and they're telling me right now that y is the midpoint of that segment. So already I know that these two segments must be congruent if y is a midpoint. Okay? So they tell us that YZ is x plus 3. And WZ, the whole segment, okay, is 3x minus 4. So they want us to determine the length of WZ. So they actually want us to find what is the length of the whole segment. So before I can do that, I have to solve for x, right? So I have to use the idea that I know that these are congruent. So if this segment is x plus 3, then YW is also x plus 3. And then I'm going to use my angle addition postulate, my segment addition postulate, and say that if I add these two segments together, x plus 3 plus x plus 3, it has to equal the total length of my big segment, okay, which was 3x minus 4. So cleaning this up really quick, we have x plus x, that's 2x. 3 plus 3 is 6. And then if I get all my x's on one side, so I have x over here. If I add this 4 to the other side, I get 4 plus 6, which is 10. So there's solving for x, so x equals 10. So they want us to actually find the length of WZ, the entire segment. So that's just a quick little plug and chug there. 3 times 10 minus 4. So what would that be? 26. Okay. So there we go. So I'm going to have you guys try B here, where it says that RM, so we have to look at this given. Sorry, missed that. So it says, given that M is the midpoint of RS. There's my picture. Use the given information to find the missing values. So they're saying that RM is x plus 3, MS is 2x minus 1. They want you to find x and then find RM. So go ahead and try that one on your own. Okay. Hopefully you found that x was 4, that making RM a length of 7. Okay. All right, next I want you guys to find C. If RM is equal to x plus 6, so again, it's the same picture. We have our length, RS, with M as the midpoint. So if RM is x plus 6 and RS, the total segment, is 5x plus 3, solve for x, and then solve for SM. Okay, if you solve that correctly, you should have got that x was 3 and SM was 9. Okay, so that's how we can kind of combine our segment addition postulate and midpoint to find the length of segments. Okay, so it's a lot of algebra there. All right, one last vocab word for the day, and that is bisect. So when you bisect a geometric figure, you divide it into 2 equal congruent parts. So they're going to have us look at this situation where a line segment WZ bisects XY at point Z. Okay, so we have a line segment XY, and they're saying at a point Z, it gets bisected. So this segment, we're going to call it WZ. Okay, it bisects that XY at that point Z. So what are 2 conclusions we could make about it if we know that a bisect means you divide it into 2 equal parts? So what does that tell us? What conclusions can you get from that information? Okay. Well, one conclusion I got, which I made with those red tick marks, is that means that XZ has to be congruent to YZ, right? Okay, so if it bisects it, it's going to divide it into 2 equal parts. So my second conclusion then is, what would that make Z? What is Z then? Hopefully you said that then that makes Z a midpoint, okay, of segment XY. Okay. All right, so we're just going to finish up on the next page with some try these examples. So I'm going to have you guys just do questions 16, 17, and 18. So 16 says, Mika knows that GH equals 7, HJ equals 7. Based on this information, he claims that point H is a midpoint. Is his claim necessarily true? And if you say yes, okay, then you think it's true. If you're saying false, then make a sketch that kind of acts as a counter example. Okay, so is Mika necessarily true? If those 2 segments are the same measure, does that make H a midpoint? What do you think? All right. So it's not necessarily true, okay? It'd be true if all of his points were collinear, but they don't necessarily have to be because they didn't talk about anything being collinear. So here's a sketch that could be a counter example here, where we have kind of 2 segments that are just put together, okay? But H is not a midpoint because it's not in the middle between our G and our J. Okay, question 7 says, given T is a midpoint of JK, JK is 5x minus 3, JT is 2x plus 1. They want you to find the length of JK. So make sure you solve for x first, and then substitute that in for JK. See what you get. Okay, if you got it correct, you should have got that JK was 22. All right, and lastly, AB lies on a number line. The coordinates of point A is -6, and given that AB equals 20, what are 2 possible coordinates for point B? So here's the answer for that, and I'm going to go through this one because it's a little different. Okay, So we have AB lies on a number line. The coordinate for A is at -6. So let's maybe put in a number line here really quick. So we'll start here at 0. So 1, 2, 3, 4, 5, 6. So here's -6. So that they're saying is where point A lies. And they're telling you AB has a length of 20. So we have to figure out what two possible ways to find the coordinates of B. So what that means is B could be 20 units to the right, okay? Or B could be 20 units to the left. So if you wanted on the number line, you could just count 20 over, right? So we're at 6 here, so that'd be 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So B would have to be here. So that would be at point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So positive 14. Okay. Now, if you had to find the other possible way, you would just start at A at -6 and count over 20 to the left. So that's how they got -26. Okay. All right, guys, that is our first lesson in activity 4. So come back tomorrow when we talk about angle and angle bisectors.